I love the fact that I have seen every where there are focus on the target in me. You like to serve the however, that is in the way as well. I don't need it. The Bhagavan is it. You get to the result. I see my higher. So, when after the Thompson message and message from that hello, please confirm that you can see me as well as you can see the service. You should just start 1 minute. You should just start in 1 minute. So we shall start. Good afternoon, good evening, everyone. My name is Afuj. I am a research scholar in agriculture and food engineering department from IIT Kanpur, and I will be taking your live interactive session for the course Data Analytics with Python. So what we'll be doing, we'll be solving some of the objective type of questions based on the previous week's content in front of you. Okay, do try to participate. And after that, we'll be going through some of the Google Colab notebooks which I have prepared based on the previous week's one. Okay. So that we'll try to see. So let us start with the very first question for the presentation. That is this one. For categorical data with n categories, the number of dummy variables will be n minus 1, n plus 1, or 2n. Okay. So this particular one is the question. For categorical data with n categories, number of dummy variables will be n minus 1, n plus 1, or 2n. Okay. Do try to answer. Okay, in the chat box. That is n minus 1. Okay, good. Yes, actually, in background, waiting is going in. That is why there is a noise. Okay, I hope that my voice shall be audible. I cannot work on the noise. I think I am clearly audible. That is for far, by far most important. If I am clearly audible, then please try to bear with it. Okay. Background some meeting is going on. That is why they are doing so. I shall be, I think, clearly audible to you as far as I can see. The noise today is not in my control. Sorry about it. যে আমার দিয়ে কোনো একটা পার্টিকুলার পয়েন্টে ইকুয়াল টু ভ্যালু হচ্ছে এতটা ম্যাক্সিমাম হওয়ার কথা ম্যাক্সিমাম ভ্যালু সেটা হচ্ছে কি তার থেকে বেশি বা কম একটা আপনি ভ্যালু পেতেন এটা হচ্ছে ভ্যালু আরেকটা যেটা হলো সেটটা অ্যানালিসিস সেটটা অ্যানালিসিস কি করে করবে টাইমের রিলেটেড তো হয় কিন্তু আমাদের একটা কন্টিনিউ একটা কোয়াড দিয়ে দিও সেটা আমরা এডিট করছি এসব মানে তিনটা মধ্যে অপশন সব সেটা দেওয়া to try to answer. I think more than 10 people have joined to try to answer. After joined us, let's see. Yeah, I think quite good people have joined to try to answer this particular problem. Okay. Then you will try to see how you can solve it, how you can approach it. For categorical data with n number of categories, the number of dummy variables will be capital N, capital N minus 1, capital N plus 1, or 2n. Okay. This is the question. The correct option will be your capital N minus 1. That would be the correct option. We'll just try to go through. Okay. See, in case of your regression analysis, the categorical variables, also known as the quantitative variables, they cannot be used directly. Okay. In case of numerical modeling, they have to be converted into dummy variables. Okay. So a dummy variable will take these particular values 1 if the observation belongs to that particular category, 0 in all other cases. Why we are using small n minus 1 number of dummy variables? If a categorical variable is having n number of categories, we have to create small n minus 1 number of dummy variables in order to avoid the multicollinearity. Also, it is also known as dummy variable trap. So if you are including will of your n number of dummy variables, it will be perfectly predicted from the others, which will make regression estimation impossible. It is like that. You are having a group of suppose n number of people. 1, 2, 3, 4, 5, plus and so on up to n number of people if you are having. And out of these n number, you just have to select one person for the post of the president. For a particular post of a president, okay, you have to select any one person. Okay. So for that particular problem, you are taking all n number of possibilities into consideration. But if suppose one another possible question is there that out of 1, 2, 3, plus and so on, n number of people, how many number of handshakes are possible? This is the particular problem. Okay. In this particular problem, what you will try to do, you will try to eliminate n minus 1 number of people. Why so? Because in this particular case, one person cannot shake hand with his own hand. He will be shaking hand with another person. Okay. So in this particular case, what will happen? N, first of all, n number of people in total are there. So for first handshake, what would be the number of people with which he can shake the hands? N minus 1. For the second person, it would be n minus 2. Okay. For the third person, it would be n minus 3. Plus and so on up to the last person would be there. He would be shaking hand with n minus 1. That is only one person. That will come to 1 only. So 1 plus so on up to n minus 1 number. That would be the total number of handshakes that would be taking place. Okay. So similarly, you can understand that you have to create n minus 1 number of dummy variables in order to avoid the perfect collinearity. or to eliminate the dummy variable trap. If you are including all n number of dummy variables, okay, one variable can be partly predicted from the others. It will make regression impossible. That is what I want to say. Okay. Now you see one another example I have played. Suppose a variable education level is having three number of categories, which are undergraduate, postgraduate, and PhD. So n is three here. So n minus one, that is two dummy variables we have created, d1 and d2. So in this particular case, undergraduate, postgraduate, and PhD. Okay. So d1 can be 0, d1, d2 can be 0, 1, 0, 0, 1. If you create three particular d3 also, then it will not make any sense, as you can see here. So the category undergraduate will become a base category, okay, or the referential category. That is the so key idea is that the number of dummy variables has to be n minus 1. Okay. It will always prevent the dummy variable trap in case of your regression models. So correct option would be small n minus 1. Okay, do try to remember it. How many number of dummy variables you have to create in order to create regression map for multi-collinear data analysis. Okay. That you must try to through these particular examples. Two examples I have provided you. Okay. If any doubt is there at any point of time, feel free to ask. There is no particular problem in asking. You can unmute yourself, you can share your screen also, I think. Just contact them. Let's move forward. In estimation of regression parameters, the likelihood function is a function of only sigma. The values beta i's and sigma should be such that they minimize the likelihood function or both A and B or all of them. Okay. So this is a particular question. Yeah. Sorry about that. I think I pressed the wrong button. Both A and B and all of the above. You try to answer this particular question, then we will discuss, okay, about the maximum likelihood function. বলবেন ভেরিফিকেশন ভুলবেন ভ্যালিডেশন সেগুলো আইএস স্ট্যান্ডার্ড দেওয়া হবে কত হওয়া উচিত তার বেশি হলে ধরুন একটা ভ্যালিডেশন আমি হয়তো মেবি 1 ঘন্টা কি 1.5 ঘন্টা আমি স্কুল থাকতে পারি কিন্তু বেশি আমার থাকতে থাকি লাভার আমি হ্যান্ডেল করি হ্যান্ডেল যখন আমি স্কেলিং দিয়ে কন্ডিশন বেশি ভ্যালিডেশন করতে তুমি কি হয় তার একটা চার্ট আছে যে এই সময় তো আমি এই ভ্যালিডেশন আমি একটা ইনস্ট্যান্ট করছি আর বেশি হলে একটা ইনস্ট্যান্ট করতে পারবো see, okay. Good. You try to answer the rest of the students also. Try to give your opinion. No need you have to be correct in the very first one. Okay, just try to give your opinion. That is very, very important. See, okay, good. Estimation of regression parameters, the likelihood function, the function of only sigma, the values of beta 0, beta plus and so on up to beta n and sigma should be such that they maximize the likelihood function, both A and B and D, all of them. Okay. This was the question and the mixed response is C and A. Okay. Let us go through. Only B would be correct. Okay. Only B would be correct. Neither C, neither D, and neither only A would be correct. Only B would be correct. Let us go through why. So now you try to see in case of your regression analysis, we will estimate the maximum likelihood estimation. Using maximum likelihood estimation, you are estimating the parameters of the regression model. And if the regression model is of the basis this particular y, capital Y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus and so on up to beta n xn plus and epsilon. This epsilon is your random error. It is crept into the model. Okay. And sigma is your standard deviation of the inner curve. Right. Beta i's, all the beta i's, beta 0, beta 1, beta 2, plus and so on up to beta n are your regression coefficients. So, likelihood function, if you would like to talk about the likelihood function, measures how likely the observed data are for given parameter values. Okay. In case of your regression, the likelihood function is likely to depend on beta i's and sigma. That already you can see. So the parameters are chosen to maximize or the likelihood function. Okay. While we are trying to maximize so that error terms are negligible. Okay. The error has to be always minimized. Error of the model and prediction has to be minimized. And that is why we are trying to increase the maximum likelihood chance. If you try to keep it in your model. Okay. Maximum likelihood estimate you are trying to, or you are trying to maximize the likelihood function because every time you are trying to minimize. Okay. So the likelihood function is a function of only sigma. No, it is incorrect. It depends on beta parameters as well as on sigma. The sigma is the standard deviation. Not only on sigma. That is why statement one is incorrect. If it is only word is cut here and sigma and beta are not there, then this particular option will be correct. Values of beta 0 plus and so on up to beta n, that is beta i's in particular, or if beta is written, that was also true. And sigma should maximize the likelihood distribution. Yes, it should maximize the likelihood distribution. Values of beta i's and sigma should maximize likelihood function, and that is correct. Okay. This is the exact principle of the maximum likelihood estimation. Both and B, since A is not correct, okay. So both A and B won't be correct. All of the above won't be correct. Okay, so correct option would be this one. This you try to pursue. Okay. Now let us move forward to the second question. Oh, sorry, third question. In case of your logistic regression, the null hypothesis tested is x0. Okay, this is like this, right? Then underscore is 0. Okay, yes. Beta equal to 0. Beta not equal to 0. That is the second option. Okay, mu is equal to 0. And mu is not equal to 0. So these are the null hypothesis. First, second, third. Which option should be correct? That is the ultimate question. Only one response to let A. Okay, what? Others also please do try to recall and try to answer. Exams are very near. If you are attempting the course for certification, I highly recommend that you go through all the pre-recorded videos, solve all the assignments, watch the recordings of this live interactive sessions as well. If you are unable to watch, please go through the PDF. Thereby, you will get a better idea how questions can be in the examination. Why this is all the content which is there for this particular course. That is my sincere advice to you all. Please do follow. In case of your logistic regression, you will have to use tested is beta at 0, beta equal to 0 equal to 4. Here. Try to at least give your opinions, then we can discuss which option will be correct. Okay. I think the vibration is very less because the meeting has ended. Sometimes it is also not in my control. And this is official meeting. So I really apologize for the noise, but now I think there will be very less or bare minimum noise. Because meeting is suspended in the same room, a lot of things carry out, and in that same room only I have to take the class. That is why there was noise for the last 24 minutes or 28 minutes. Now you try to see here, okay? This, yeah. The correct option would not be, it would be A. Okay. It would be A only. Okay. Two students have answered, they have answered it perfectly fine. It would be like this. Okay. In the examination, you might be given like this H0. So don't get confused, sir, where this term has come. It's nothing but this one. Null hypothesis. It is not written in the subscript, so don't get confused. Okay. So please bear with it. Now, the correct option would be this one. Already we have explained. Try to see. In case of your logistic regression, you are trying to predict the, you are trying to model the probability of an event using the logit function. Okay. This particular one is your logit function. Logit function is defined like this. Log this exponential by default. Okay. P over 1 minus P. Okay. That will convert to beta 0 plus beta 1x. Beta 0 plus beta 1x. Why I am writing? So that with me, you also write, you try to jot it down thereby. Or if you have watched our lectures, recorded lectures, then you must be knowing. And even if you are knowing, try to note it down before the examination so that you can recall it in the examination. So it is log P over 1 minus P equal to beta 0 plus beta 1 x, where P is the probability of the event, x is the independent variable, beta 0 is your intercept, and beta 1 is your regression coefficient. And to check whether the independent variable significantly affects the response, you need to test the coefficient beta. Okay, these beta i's. That is what I am referring to when I say the term beta. Okay. Null hypothesis I have formulated it as 0 as beta equal to 0. Alternate hypothesis I have formulated as H1. Okay. Null hypothesis was at 0, beta equal to 0. Null hypothesis is opposite. It is beta is not equal to 0. Okay. So interpretation is if beta is equal to 0, then the predictor variable has got no effect on the probability of the outcome. And if beta is non-zero, then the predictor variable significantly influences the outcome. Okay. So you are checking the options. H0 is beta equal to 0, H0 beta not equal to 0, mu equal to 0. Mu equal to 0 is used in mean test, not in case of your logistic regression. Logistic regression is basically concerned with beta 0 and beta 1. Or in short, if you are writing beta i's. Okay. So yes, beta equal to 0, that option is correct. Okay. Beta non-zero, this is alternate hypothesis. If it is written H1, okay. Maybe it is a multiple select question. In that case, it might be written H1 is such that beta is equal to 0 or not equal to 0. In that particular case, this would be correct. Okay. Only in that particular case in which the null hypothesis or the alternate hypothesis I have formulated as beta is non-zero. So H0 is beta equal to 0, H1 is beta not equal to 0. So this one is your alternate hypothesis. This one is the correct alternate hypothesis. Mu is nowhere related, so this will be correct, this will be correct, and this will also be incorrect. Okay. Final option would be like this. Beta is equal to 0. Now you try to answer this particular question. In case of your logistic regression, the graph does not follow the S-shaped curve. The dependent variable is categorical. The estimated value of dependent variable is not probability or D none of the above. You try to answer this particular question. In case of your logistic regression, the graph does not follow a shaped curve. The dependent variable is categorical. The estimated value of dependent variable is not probability or D none of the above. Right was. Okay, the graph does not follow a shaped curve. Okay, good. The rest of the students also take your time, but try to answer. Try to be responsive. This is for your own good. Okay. B. Okay. Good. In case of your logistic regression, okay, this was the question. The graph doesn't follow a shaped curve. The dependent variable is categorical. The estimated value of dependent variable is not probability or D none of the above. The correct option would be what? The dependent variable is categorical. Okay. B would be correct. The graph does not make sense here. It follows a shaped curve. Okay. Estimated value of dependent variable is not probability. No, it is probability. Okay. None of the above will not be correct. Let us go through. In logistic regression, it is generally used when the dependent variable is categorical or it is separated into categories, binary categories, 1 or 0. Okay, two particular categories are there, two classes are there. Okay, for example, disease description. It is yes or no. Whether email, you have to classify into two particular categories, 1 or 0. It is spam or not a spam. Purchase, whether you want to buy it or you don't have to buy it. Okay, decision making. Okay, 1 or 0. Logistic regression model, I already taught you the equation. Okay, in previous question, I tried to tell you about that. The same equation is written here in modified form. Okay, taking 20 log both the sides, and then you have just written this that particular equation only in this particular form, which is P equal to 1 upon 1 plus e to the power minus beta 0 plus beta 1 x. Okay, this is the equation which we have derived. Okay, it will always produce an S-shaped curve. Okay, S-shaped curve like this, and there would be a gap. Why there would be a gap? Because you must have studied in class 12 domain and the function values. Okay, domain and range. The concept of domain and range. Xi can take any of the values. Okay. If you try to see the curve of e to the power minus x, how it will be? It will be like this. Okay. So 1 over 1 plus anything, okay, that will always be less than a particular range. Okay. It means it can be capped. That is why we have provided two particular caps. Okay. And 1 over x. What is the nature of that particular curve? It is just like this particular half. Okay. This particular half of the curve, if you will see, that is the exact nature of the curve of 1 over x. Okay. So from that only, you try to remember that the graph of 1 upon 1 plus e to the power minus beta 0 plus beta 1 x. That is your logic function that will always be S-shaped curve. Okay, that is the thing. If the graph does not follow S-shaped curve, no, it is not correct. Logistic regression will follow an S-shaped curve. Dependent variable is categorical. Yes, it has to be categorical. Okay, classification problem. Logistic regression used for categorical outcomes. This is true. The estimated value of dependent variable is not probability. No, it is probability only. Okay, P in the logistic function, which I have written here, it is nothing but your probability only. Here it is written probability of an event. Okay. Then the none of the above. No, it won't be correct. Okay, estimated value is not probability and estimated probability is between 0 and 1. But you can see from the nature of the function only. Okay. P has to be 1 upon 1 plus e to the power beta. So try to remember. Okay, 1 over 1 plus e to the power minus beta 0 plus beta 1 x. And since it's a probability, it would be between 0 and 1 only. And from the nature of the curve, it would be what S shape curve only. Okay, you should please try to remember. I am writing today a lot of times because now your exams are near. You need to remember the functions, remember the properties. You have to remember a lot of data as well as you have to solve the questions also. Whereby you will be able to perform well in the examination. So that is the thing. If it is your linear regression, okay, if it is your linear regression, then the general equation is of this particular form. Okay, beta 0 plus beta 1 x1 plus beta plus and so on up to beta n xn plus epsilon, which is the error term. Okay, this is the case of your multiple linear regression. Okay, these all are the values. Okay, which are now don't concentrate about this 0 and 1. Just for the reference, you try to remember. Okay, there is no hard and fast rule that in case of your linear regression, the gap will be always there. Okay. So for particular linear regression, you can note down that the figure would be somewhat like this. Okay, the graph would be something like somewhat like this. But when it comes to your logistic function, okay, or always, or it is also known as sigmoid function, it would be like this. It would become an S-shaped curve, and the equation would be of this particular form: y equal to 1 upon 1 plus e to the power minus beta 0 plus beta 1 x1 plus and so on up to beta n xn. And it will always be an S-shaped curve that is kept between two values, that is 0 and 1. Okay, this will try to show. Now comes to your question number five. Okay, question number five is like this. To state true, false. G static is used to check the individual significance of independent variables. Whether it is true or false. If you know G statistic, then only you would be in a position to answer this particular question. Okay, try to answer. B. It is true. Good. B. Good. False. Okay. B. B. Okay. The rest of the students also try to answer. D. Okay, good. The correct option would be B only, false. Okay. Now try to see here. In case of your logistic regression, okay, different statistics are used for the particular purpose. G statistic is your likelihood ratio test, okay, and it is used to test the overall significance of the regression model, not of the individual variables. It will provide no information about the applicability or about the influence of the individual models. Okay, and the formula is G equal to minus 2 ln L0 divided by L1, where L0 is the likelihood of the null model without any predictors, and L1 is the likelihood of the full model with predictors. Okay. It is used to test whether the model with predictors will fit significantly better than the model without predictors. Okay, that is the particular problem which is it is trying to solve. It is used to predict, it is used to test whether your model with predictors will fit significantly better than model without predictor. That is the particular use case scenario of your G statistic test. Okay. Now you see individual significance of variables. If you want to test that individual significance of variables, you can use go ahead for world test or world statistic. Okay. And your hypothesis has to be beta I equal to 0. It is used to check whether the specific predictor will affect the response variable. So G statistic test will not test the, it will test the overall model significance, not the individual variable significance. So correct option would be false only. And if the question is the value test tests the overall model significance, not individual uh, variable significance, that statement will also be false. Okay. Here, G statistic is used to check the individual significance of the independent variable. It is false. It is used to check the overall significance of the independent variables. Overall significance of all the variables. And in place of G statistic, if I use weld test, okay, weld test, that particular statement will be correct. Okay, weld test is used to check the individual significance of the independent variables, that statement would be true. So you just try to keep it in mind. Okay. Let us move forward. When it's in case of your statistical estimation, the maximum likelihood estimate, okay, or the MLE of a parameter is defined as the value of that parameter of the parameter that minimizes the variance of the estimator or maximizes the likelihood of observing the given sample data, minimizing the sum of squared errors, or maximizing the mean of the sample. Okay. You try to solve this particular question. In case of a statistical estimate, the maximum likelihood estimate of a parameter is defined as the value of the parameter that maximizes the variance of the estimator, maximizes the likelihood of observing the given sample data, or minimizes the sum of squared errors, or maximizes the mean of the sample. So try to answer. A. Minimizes the variance of the estimator. Okay, good. B. Okay, good. Maximizes the likelihood of observing the influence afterward. Is B. Maximizes the likelihood of observing the given sample data. Okay, good. Yes, the correct option would be B only. Okay, maximizes the likelihood of observing the given sample data. Okay, that would be correct. Why is it so? Because the maximum likelihood estimation MLE method is used to estimate unknown parameters of the probability distribution. Basic idea is you try to choose the parameter values that make the observed data most probable. Okay. So the likelihood function L as a function of theta, where theta is the parameter value, then the MLE, maximum likelihood estimate, is obtained by theta equal to maximum argument value of this particular L theta. Okay, where theta hat is the estimated value and the estimated theta hat which you are getting, it is the value of theta that will maximize that particular likelihood. So for your binomial distribution with x successes and number of trials, the maximum likelihood estimate of probability p would be x over n, where x is successes and n are the number of trials. Okay. So the value of p will make the observed sample most likely. So concept of likelihood, maximum likelihood estimate when use as a table I have given here. Likelihood, what is the real meaning? Probability of observing the data given parameters. Maximum likelihood estimate is the parameter that maximizes that particular likelihood. And use case is in your regression, in case of your logistic regression and many statistical models. Now let us move forward to the seventh question, which is straight true or false. Another straight true or false type of question. Yes. The method of least squares. The method of least squares can be applied to models with any probability distribution, whether it is true or whether it is false. Method of least squares can be applied to models with any probability distribution, whether it is true or false. So try to answer. B and A, okay. False and true, highly converging. A statement can be true or a statement can be false. What do you think? Can it be true and false at the same time? What is your opinion about that? It is just like a logic gate. Okay. And or not or XOR, it's not. It can either be zero, it can either be one. It cannot be one and zero at the both at the same time. If it is so, then the entire data on the disk will corrupt. That is it. It cannot be read. So two people are saying B, one is showing A, but let others think also. Method of least squares can be applied to models with any probability distribution, whether it is true or false. But of least squares can be applied to models with any probability distribution, whether statement is true or false. Think in answer. Three false. Okay, three people have joined the group of saying it. False. Okay. Good. Yes. Now we try to see it would be false only. Okay. Method of least squares can be applied to models with any probability distribution. This particular statement would be false. Okay. Method of least squares or the your OLS, ordinary least square regression, it will try to estimate the regression best parameters by minimizing the sum of squared residuals. What is the sum of squared errors? That is yi minus y hat. Okay. That is the difference between the observed value and the predicted value. Square of that you just try to minimize the sum of squared errors. Okay. So the classical least square method is mainly suitable for models where the error term follows a normal distribution. The response variable is continuous. It is not appropriate for all of the probability distributions. Okay. In case of your linear regression, then distribution is normal. Estimation method is ordinarily least square regression. In case of your logistic regression, the distribution is binomial. The estimation method is maximum likelihood. In case of your Poisson regression, the distribution is Poisson. Estimation method is maximum likelihood. So the models with binomial or Poisson distribution, they generally use the maximum likelihood instead of OLS, ordinary least square regression. Whereas in case of your linear regression where the distribution is normal, the method, estimation method is generally ordinary least square regression only to reference. The rest, both of the cases, we go to the maximum likelihood state. So the method of least squares can be applied to models with any of the probability distribution. That is not true. It can be applied to only normal probability distribution. Normal distribution. In that particular cases, in that particular case, we will try to apply the method of ordinary least square regression. While in case of your logistic regression or the distribution when it is binomial or Poisson, you will use go for maximum likelihood estimation. Method of least squares can be applied to models with any probability distribution. No, because least square is not suitable for all of the distributions, especially which are one with are estimated with binomial or distribution. Correct option would be false. So question number 8 is suppose you have been given a fair coin and you want to find out the odds of getting heads. Okay. Which of the following option is true for such a case? Odds will be 0, odds will be 0.5, odds will be 1 or none of these. Okay. This will try to explain. Suppose you have been given a fair point and you want to find out the odds of getting heads. Okay. Which of the following option is true for such a case? Odds will be 0, 0.5, 1, or none of these. What's your take on this particular question? Do try to present B. Good. C. Odds should be 1. Okay. Then C. Odds should be 1. Okay. C. Odds should be 1. Okay. B, C, C, B. Okay. Good. E. Okay. Question number 1. Good. Okay. Yes, correct would be odds will be 1 only. Okay. So why so? Question was, suppose you have been given a fair coin and you want to find the odds of getting heads. Okay. The probability of heads for a fair coin would be 0.5. Probability of tail would be 0.5 for a fair coin only. Okay. Definition of odds is odds are defined as the ratio of probability of success to the ratio of probability of failure. And in this particular case, the probability of success to probability of failure, since the probability of what is success? Success is getting head. What is the probability? Probability is 0.5. Then failure is what is the failure? Failure in this particular case is getting tails. And what is the probability of getting tails? That is 0.5 only. So 0.5 divided by 0.5 will be equal to 1. Okay. So the general idea will be 1 only. Odds are always 1 is to 1 means the chance of heads and tails is equal. Okay. Odds equal to 0, that is incorrect. Odds equal to 0.5, that is also incorrect. Odds equal to 1 is correct, and none of the options would be incorrect. And now one supplementary question I'll be asking you all. What is in the same line? Okay, in the same line, you use the same particular formula and try to answer what are the odds of getting 1 in a throw of a fair die. In a throw of fair dice. Okay. Probability of odds. Okay, odds of getting 1. Okay, of getting 1. Odds of getting 1 in a throw of fair dice. Okay, you try to calculate this. Okay. Try to calculate. One student is saying 16.7%. Okay, we will see. Odds of getting 1 in a throw of fair dice. Okay, you try to calculate. Only odds. Okay. I'm not talking about the probability. I'm talking about odds. Okay. In this particular question, it was asked odds. Okay. Jayapritha is try to understand odds. Odds. Okay. Odds would be probability of success divided by probability of failure. Okay. You try to just keep this in mind. Try to edit or you try to think in this particular manner. Okay. I'm not talking about the probability of getting 1 in a throw of fair die. That would be 100% 1 by 6. But what will be the odds? Okay. 20%. Good. You try to calculate what are the odds of getting 1 in a throw of fair die. Okay. So if we go for this particular formula, what is the definition of odds? Odds is nothing but probability of success divided by probability of failure. What is success in this particular case? Success is getting 1 in a throw of fair die. How many number of faces a dice is having? 6 number of faces. And on each face, these numerals are there. 1, 2, 3, okay, 4, 5, and 6. Okay. So, what is success? Success is getting 1 in a throw of a fair die. Okay. So if I am getting 1 means what is the probability? Probability of success becomes 1 by 6. Okay. When I throw of fair die, what is success? Success is getting 1. Okay. And what is the probability of an event? Favorable outcomes to the total number of outcomes. Total number of outcomes is 6. What is the favorable outcome? Favorable outcome is 1. Okay. So probability of success is 1 by 6. What is the probability of failure? Failure is nothing but 1 minus 1 by 6. Okay. So what only two possibilities are there in this particular case. Okay. So 1 minus 1 by 6, either you take it like this or getting anything except 1. So 5 numbers are there, 2, 3, 4, 5 and 6. So it will be 5 by 6. So there it would be 1 over 5. Okay. And what is 1 by 5? It is nothing but 20%. Okay. So in the same format manner, you try to understand this. If odds are asked, then you keep it in mind. Okay, answer accordingly. And if it is asked that what is probability or what is the probability of the event, then you answer accordingly. Okay, sir, please tell again. I'll tell again. I was asking you that in the same format manner, I have talked about the coins. Okay, probability definition of odds in case of throw of a coin. I was asking you what are the odds of getting one in a throw of fair dice. Okay. So how to calculate the odds? First of all, a fair die will be having how many number of faces? Six number of faces. So that will be 1, 2, 3, 4, 5, 6. Okay, you must have seen a dice in the game of Ludo and you must have played it. Okay, well in your childhood days. So it is having six number of faces 1, 2, 3, 4, 5, and 6. These are the six numerals, okay, which are there on the face of a dice. Okay. So if you try to calculate what are the odds are nothing but probability of success divided by probability of failure. The success in this particular case is what is success? Success is getting one. Okay. So one getting only this particular numeral. Okay. What is success? Success is getting one. Okay. So what is the probability of success? That is 1 by 6 only. Okay. Getting 1 in 6 number of possibilities. So probability of success would be 1 by 6. Okay. Getting 1 in a fair throw die, the probability would be 1 by 6. And probability of failure, okay, means getting any other numeral other than 1. Okay. So what will be the probability? Either you can say 1 minus 1 by 6, that will also be 5 by 6, or you can just count it here. Like you don't want 1. So how many numerals are left? 2, 3, 4, 5, and 6. Okay. So 5 numerals are left. So the probability of failure would be 5 over 6. And if you solve this, it will come as 1 by 5. In percentage, it would be 0.2. And then in fraction, it would be 0.2. And in percentage, it would be 20%. This is what I was trying to say. If it is clear, then tell me. The rest I will explain once again. Clear? Okay. Good. If any doubt is there, then feel free to ask. I'll explain it once again. Okay? No problem. Okay. Let us move forward. Large values of log likelihood statistic indicate that there are greater number of explained versus unexplained observations. That is, statistical model fits the data well. That the predictor variable increases. As the predictor variable increases, the likelihood of the outcome occurring decreases. That the statistical model is a poor fit of data. These are the four number of possibilities. 1, 2, 3, and 4. C also. Okay, sure. B. Good. B. Good. If you try to see here, okay, correct option would be B only. Okay, B. Large values of log likelihood statistic indicate that the statistical model fits data well. Okay, it won't be C, it won't be A, as well as it won't be D also. Okay. What is the log likelihood? In the case of your statistical modeling, such as your logistic regression or your maximum likelihood estimate, the likelihood function will try to measure how probably observed data are given given in a set of model parameters. Okay, how probable the observed data are given a set of model parameters. So that you try to calculate using the log likelihood, which is nothing but the simple logarithmic of the observed data. Okay, you take the observed data, you calculate the log of that particular value. What is the meaning of log likelihood value? That higher the log likelihood, the model explains the data value better. And lower the value is, model explains the data poorly. During your estimation, the goal is to maximize the log likelihood. Okay, it is always to maximize the log likelihood. What is the interpretation in case of a model fitting? If the log likelihood value is large, it means that the predicted probabilities from the model are close to observed outcomes and the model fits the data well. Okay. But if you are checking the options, then greater number of explained versus unexplained observations. This was option number A. This is not the definition of log likelihood. Model fits the data well. This I already explained to you. It is correct. Predictor increases, outcome decreases. It refers to the slope, not the case of log likelihood. Okay? And poor model fit, it is opposite of large likelihood. Okay. So option number greater than number of explained versus unexplained observations. This is also not correct. If predictor variable increases, the likelihood of the outcome decreases. No, opposite of that is true. That the statistical model is a poor fit of the data. That is also not correct. The statistical model fits the data well. That is the meaning of log likelihood of observations. Okay. Now you try to see this particular question, question number 10, the logit function that is L of x is the log of odd function. What could be the range of this logit function in the domain when x equal to belongs to the closed range 0 to 1? That is the question. And options have been given minus infinity to plus infinity, 0 to 1, 0 to infinity, minus infinity to 0. Now we'll try to explain what's your take on that. A is good. Yes, A, and A, good. Very good. Yes. If you try to see here, correct option would be A only, minus infinity to plus infinity. Why so? What is logit function? Logit function is the logarithmic of odds of the probability P. Okay. So L as a function of P is log P over 1 minus P. P is the probability and it ranges between 0 to 1. What is the domain? Domain of the probability function or the probability P lies in the interval 0 to 1. What is the range of the logit function? Let's check the extreme events. If P tends to 0, if P tends to 0, then P over 1 minus P. Okay, P over 1 minus P. P chance, if you take the value P as 0, then this particular term will be 0. Log 0 is minus infinity. So from here, first value of this particular range I have got as minus infinity. Okay. Now I will check for the another function value, that is P as when it tends to 1. So P when tends to 1, then this P will be 1, 1 minus 1 minus 1. Okay, 1 minus 1 is 0. And in numerator it is 1. So 1 over 0 is infinity. Log of infinity is infinity. So LP tends to infinity. Final range is minus infinity to plus infinity. Rest all the options will be incorrect, which are mainly B, C, and D. Correct option would be A. So this marks the end of the 10 questions, objective questions, which I wanted to discuss. Let us move forward for the next part of the session, in which we will be going through some of the Google Colab notebooks. Okay. We'll be going through some of the Google Colab notebooks, in which we'll be seeing some of the concepts regarding the practical implementation of these particular topics. Okay. Yeah. So Here you just try to say, I have tried to uh, implement the concept of date and time. Okay. Date and time. So I have imported from date time library this particular date and time. Okay. Just 1 second, I'll show you date time library. Date time is this particular basic data and time type. This is the library date time.py. Okay. So this particular module, it supplies classes for manipulating dates in time. Okay. And while the data and time provided is always arithmetic, okay, arithmetic according to the network IP time zone. According to the network IP time zone, it will try to provide the date and time. Okay. The focus of the implementation is on efficient attribute extraction for output formatting and manipulation. So various descriptions have been provided here. What are the constants? Okay, what are the available types and object with respect to time, data, date time, time zone. These are the particular subclass relationship diagram that has been provided here. Okay. Then various functions, distribution, how it will try to provide us the time in millisecond, minute, hour, week. Okay, this is the thing. And these are some of the sample codes which you can just try to see. Okay, try to copy and try to paste in the Google Colab cell. Then you try to run. This you can do yourself. This is regarding time, date time library. Okay, as well as what are the different operations and what outputs you will be getting after the operations, which you can see from this documentation page. Okay. For your reference, I'll just paste the link of this particular web page or the documentation page. I paste it here. Okay. After the class is over, try to visit various attributes and try to check, verify here only. Okay. So exact overflow, whether it can overflow, not overflow, data type attribution, various attributes, okay, that particular documentation page is this one. Okay. Try to go through yourself. Okay. How it is able to fetch the date and time and how you are able to manipulate different date and time values which it gives. Okay, so that particular manipulation I try to carry it out in this particular Colab notebook, which I have imported the date time. Now, from date time dot now function, I am trying to print the date and time of this particular method. Okay, so it has given me in American date format 17/3/2026, and according to my time zone, it has provided me the values. Okay, these particular values to time values it has provided. Try to see in this particular documentation that on what basis you can segregate it. Okay. So now dot year, if I press, then it is giving me year. Now dot month, it is giving me month. Now dot day, it is giving me the day today. Now dot year dot now dot month now dot day means everything. If you try to calculate, okay, once at this moment, it will give you the exact date, year, and month of today. Delta as a function I have calculated, try to calculate the means difference between two particular dates. Okay, two particular dates. So it has given me days and seconds as the difference between two particular date and time. Okay. So how many number of days are there? Then time delta as a function also you can import. And starting date time you can provide. Then plus 12 means 12 number of days you can increase. Okay. Then start minus T time delta. These are general operations, okay, which you can perform using the date time library. Okay. Then you can classify the particular date into year, month, and day. Okay. Then various manipulations we have carried out here when pass the today's date, today's time, and pass it to that particular library also. Okay. Then using the pandas library, what we have tried to do is we have tried to perform this particular manipulation, date and indexing. Okay. So month, year, then clockwise, everything we have tried to do. Now, this was regarding date time library. Okay. Segregating the data, calculating the difference between two particular dates, calculating the exact number of minutes, days, seconds between two particular dates that we have provided here. Now you try to see, I have used a particular open source stock data, stock enterprise data, and try to manipulate it. Okay. So this or try to do some data analytics with this particular data. Okay. So this particular URL I have provided, then I have written, I have called it in this particular clause underscore ex dot all. Okay. And as a pandas data frame, I have tried to convert this particular URL, okay, link. Then printed the head. Head means top five rows. Okay, that I have tried to print. Then from all, if I call this particular function, okay, I printed the data set in raw format. Then first five rows and the last five rows, it will try to provide me and it will try to give me what are the number of rows and columns. Okay. Then I have created a subset from particular pandas data frame and that pandas data frame subset is open, high, low, close, and volume. And then I have tried to call it. Then I have tried to plot the open values. Okay, these are the values from the dataset columns only: open, high, low, close, adjacent, close, and volume. Try to plot these particular values. Okay. After plotting, I have tried to formulate a time series. Okay, means from a particular date value as well as a time value, I have tried to stamp it with the particular rows and columns of the data. Okay, so that particular manipulation I have done and I have got the particular time series. Here overlap is there. Okay. Right, when you will increase the size, okay, size of this particular graph, then overlap will be eliminated. So you can clearly see the date as well as the time. Then I have imported all the uh, value, all the functions from the pandas dot time series access. Okay. So hour value, then range value, then hour plus minute. These are different types of manipulations I have provided. Then coming towards the second part, I have imported date time, then what is the data now. These are the same things which I explained you earlier. Okay. Just the values I have changed in order to explain you. Then converting date and time into string, okay, string format as well as different other formats are there. So you try to see yourself with this particular manipulation. Okay. This is nothing but the same repetition of the previous values. Okay. Previously, I have explained the date time various attributes of the date time value. Okay. Then not a number, NaN, not a number, NAT is not a time. Okay. So if it is not in the correct format, it will return it as NAT. Okay. So this is the regarding index ranging, what are the different values, different manipulations between two particular dates that we have provided here. Okay. After the class is over, try to download this particular Colab notebook. Try to search in the Google Colab. Okay, then this particular page will open. Then go here, upload. Try to browse the location of that particular notebook. Okay, and then you can upload this particular notebook and try to run different values and correlate with this documentation that whether you are able to manipulate different date time attributes or not. So this is very basic regarding your time series, creating any data. Okay, this is stock market price database, open database. You can stamp it with respect to time. and you can perform various type of regression analysis with this particular data set. In future lectures, we'll go through that particular process, but the basics of stamping any time series data set, okay, that we have demonstrated in this particular Google with that version. There is nothing much to explain, only basic data manipulation which you must have carried out in your arithmetics. Calculating the days between two particular dates, calculating the number of hours and minutes between two particular hours and minutes. That has been demonstrated here. So the class is over. Please go through it. Okay. If you are having any doubts, feel free to ask me. Okay. Anytime. Much of the data manipulation you can do afterwards. Okay, if you stamp a particular data set, means particular rows and columns with time. After that, there is regression analysis, and after regression analysis, you would be able to fetch various inferences from the data set. So this is the demonstration regarding that. Okay, but after the class is over, please go through it. Any doubt comes in your mind, feel free to ask me. And this is all regarding this particular session. Thank you all for joining the session. Do join the session next week, sometime soonly, and prepare well for your examination. And if any doubt emerges, then feel free to ask me. That's it from my side. Now the session is over to you. If you are having any doubts, then you can ask me. Rest you can kindly leave. Okay, thank you all for joining the session. Do join the session next week, same time, same time. Okay, thank you everyone. Thank you. Okay, thank you so much for joining the session. We will in the session next week, same time, same link. Okay, they're well for the examinations from week 1 to week 12, and there will be one another extra summary session which I will take. Okay, for clearing all of your concepts. Okay, so do join that also. Okay, thank you. Bye. Have a great day. Okay, thank you everyone for joining the session. Okay, do join the session next week, same time, same way. Okay, I'm ending the session for the day. So, thank you once again. Have a great day.